Hello, my name is Megan Clark. I am presenting 7.1 poker odds for Dr. Gear's Math in the Modern World class on Tuesdays and Thursdays from 1:30 to 2:55. Question for today is to compute the probability of randomly drawing 5 cards from a deck and getting a pair, 3 of a kind, 4 of a kind, a full house, which is 3 of a kind plus a pair, and then a flush, which is when all cards are the same suit. And then for a pair, some important notes are that there are 52 cards in the deck and that the order of the cards doesn't matter. There are 13 different values for the cards from A to K. And then for the equation, 4C2 is how many ways there are to make a pair. 12C3 is how many options there are for the other 3 cards that are not included in the pair. And then the 52C5 is the total ways to make a hand. So with the equation on the right side of the screen, you get a probability of 42.26% chance getting a pair in a hand of cards. And then part B is 3 of a kind. There are still 52 cards in the deck. The order of the cards still doesn't matter, and there are still 13 values for the cards. In this equation, 14C3 is a way to make 3 of a kind. 12C2 is the options for the other 2 cards in that hand, and 52C5 is still the total ways to make a hand. The 4 squared in this equation is the suits for the 2 cards that are not part of 3 of a kind. And then your percentage, once you type the equation in, is 2.1128% chance getting 3 of a kind in a random hand. Part C is 4 of a kind. Once more, 52 cards in the deck. The order of the cards doesn't matter, and there are 13 values. There are 4C4 ways to get 4 of a kind, 12C1 options for the other 2 cards. There are for the other card. There are 4 suits for that final card. And then once more, 52C5 ways to make a hand, giving you 0.02401% chance of getting 4 of a kind. And then D for full house, which is 3 of a kind in a pair. Still 52 cards. The order of the cards still doesn't matter. There are still 13 values, A through K. There are 4C3 ways to make a pair. 4C2 options for the other 3 cards. For the 3 of a kind, sorry. And then 52C5 total ways to make a hand. You get 0.02401% chance of getting a full house. Part E is a flush, which is when it's all the same suit. There are still 52 cards in the deck. The order of the cards still does not matter. There are 13 values for the cards. And then there are 13C5 different ways to make the flush. And 5,184 options for the pairs. With your equation, you get 0.1965% chance of making a flush. Then suppose you have 3 of a kind. What is the probability that someone else has a higher hand? So for this equation, you add together the frequency of each of the higher hands, which is a straight, a flush, a full house, a 4 of a kind, a straight flush, and a royal flush. And then you divide it by the total number of hands, which is, once again, 52C5, giving you 0.7586% chance that someone has a higher hand than a 3 of a kind. How does this constitute better decision making? If you were to play poker, you would have a better understanding of the odds in the game, and this understanding of proportions and percentages can be applied to other areas of life as well. Thank you.